Hello, class, and welcome to the COMP-111 Week 6 lesson recording. So today is a nice short one, very easy, but very important as well. We're going to talk about test cases, and there will definitely be questions about these test cases on the final exam. So you want to make sure that you understand the different versions of test cases. So we're going to specifically talk about sufficient test cases, black box testing, white box testing, and regression testing. So just real short, just 15 quick slides, but very important as well. All right, so test methods. So I'm going to go back to this question that I asked you before when we were first introducing test-driven development, is do you need to know how a house is wired to test if a light switch is working correctly? And the answer, of course, is no, that I can go to a light switch and turn it on and say, yes, the light is turning on, and no, it's not turning on, kind of a thing. So I can go and sufficiently test a light switch without knowing how the house is wired. Okay, this is essentially black box testing. This is testing the functionality of the program without knowing how the internal structure, without knowing how the program has been written. So this tests the program from the user's perspective, how the user would actually use the program. So let's say, for example, we've written a blackjack program, all right, and we want to know if it's functioning correctly. So the user might go in and say, deal me a card, and interface with the program and try to get it to fail in some way, shape, or form. So it might say, deal me a card, and go, all right, that score is correct, now deal me another card. Okay, my first card was a 3, my second card is a 7, my total should be 10. Is my total 10? And it might say, deal me another card. In this case, it's another 10, and it would go, all right, my total should be 20. Is my total now 20? Yes or no? And then it might intentionally say, deal me another card, trying to get it to go over blackjack and seeing what the program does there. And then likewise, the user may restart the program and go through its throws, but then stop early and see what happens, and then try to hit 21 and see what happens, and then see what happens when the computer hits 21. In other words, you're just really using the program from the user perspective, trying out every single thing. Well, what if I hit this? Well, what if I hit this? What if I press this button? What if I press that button? What happens? And you're just trying to get the program to fail, making sure that it operates in every component, that everything does what it's intended to do. Okay, so testing the program from the user perspective. So this is not writing test cases. This is actually using the program, interfacing with the user interface, trying out all the different components and seeing how the program responds. Okay, so black box testing will show the presence of bugs, but will not necessarily show their absence. So it would definitely show you if there's a problem, if it adds up 3 and 7 and it gets 9 instead of 10. So that definitely tells you that there's a bug. But just because everything that you've tried worked okay doesn't mean that there is not a bug behind the scenes somewhere. Maybe it had added up 3 and 10, but maybe for some reason it's only doing bust if you get 23 and above, and it's not giving you a bust at exactly 22, but in all of your test cases you never hit the value 22. You hit 23, you hit 27, you hit 24, but you never specifically hit 22, and so that bug doesn't come up because you didn't encounter that in your testing. And likewise, we're turning the light switch on and the lights come on. So we're saying, all right, that works. We turn it off and the lights turn off. We're saying that works. But what we don't know is there's actually sparks inside of the wall, but we can't see those from our perspective. So there is a bug in there, but we didn't encounter it with the testing that we conducted. So black box testing is testing from the user's perspective, trying things out from the user's point of view, testing it as best as we can from that user point of view. It will definitely identify any bugs that we encounter during the course of our testing. For instance, if we flip a light switch and nothing happens, but it does not guarantee 100% the absence of bugs because we can't get to the internal components of the program. So think of black box testing as kind of being blindfolded. You're looking from the outside and you can only see what's visible to you, but you can't see the internal workings. All right, white box testing, on the other hand, looks inside of the program and it's tests based upon the knowledge of the program structure. So the unit tests that we've been doing, the assert equals statements, the test-driven development, that's white box testing. So we're writing a test case for each and every method in the program. So we're not only testing the light switch itself, but we're also maybe monitoring the amps and the wiring, and we're checking for sparks, and we're checking for malfunctions, and those sorts of things. So we're testing it from the internal components of the program. And that's what we've been doing all along, is white box testing. That's our JUnit testing that we've been doing. Okay. Now, one key thing with white box testing is you need to make sure that you have appropriate code coverage. And you've probably been noticing in WebCat that it's going to highlight some lines in pink and say that you have insufficient coverage, that those particular lines have never been tested, have never been executed or ran, or not sufficiently tested. And so what that is doing is it's telling you that you don't have sufficient code coverage. When you're doing white box testing or JUnit testing, you want to make sure that every single line of code in your program executes at some point in time during your test cases. So every single line in every single method needs to execute and be tested. Okay, every if branch and an if statement, just every single thing that you could possibly encounter needs to be tested inside of your program. All right, so here we have an example where we are changing the value of the gender. So perhaps this is a student and we have the birth gender, so the gender that the student had at birth, and then there may also be a preferred gender, the gender for which the student prefers to be known. All right, so in this case, we're going to change the gender to a different value, and that value is coming in. And so here we have an if statement that says if the gender is equal to a capital F or a lowercase f, then go ahead and set the gender. And if the gender is equal to a capital M or a lowercase m, set the gender. But if it's equal to anything else, then don't set the gender. So one of our test cases might be student.setGender to a capital F, and then we would retrieve the gender and make sure that it does equal to a capital F. So the question is, what other test cases are needed? And we would need 4 or 5 additional test cases in order to properly test this particular method. So we've executed this branch of the if statement here with this test case, but we now need to execute this branch. So we would want to duplicate these statements but provide it with a lowercase f. And then we want to execute this portion of the branch. So we'd want to duplicate these statements again, but give it a capital M. And then we need to execute this half of the branch. So duplicate these statements again with a lowercase m. And then we need to run into the situation where it doesn't encounter any of these at all. So we would want to give it something completely different, maybe a Q or an R or a 1 or a question mark or something totally different, and make sure that it does not change the gender, that the gender remains unchanged. Okay, so code coverage is absolutely everything needs to execute at least once in order to ensure that everything is working as it should. All right, boundary test cases. So this is another important component of writing your test cases. It could be that you're running some percentages in your program and that you have these boundaries. So in this case, we're trying to look at a grade. So we're saying if the score is less than 60, the grade is an A. If it's less than 70, it's a B. If it's less than 80, and so on. So obviously, this is not a correct statement here, right? If the score is less than 60, it should not be an A. It should actually be an E. And if it's less than 70, it would be a D, and so on. But the point of this is that we want to test the boundaries. So we would want to test what happens if the boundary is a 59. Am I getting the correct grade? What if it's 60? What if it's 61? Am I getting the correct grade? And here I'd probably want to go 69, 70, 71, and here 79, 80, and 81. I'd want to test all of those boundaries to make sure that I've got everything set up correctly. It's so easy when you're doing these comparison statements like this to just maybe use a greater than when you need to do a greater than or equal to, or to use a greater than, a less than equal to when you need to just use a less than. It's so easy to make a mistake in these situations. So you want to test all the boundaries, 59, 60, and 61. 69, 70, and 71. You just want to make sure that you're getting the correct result on these boundaries. Okay, so here's an example. We have a get tax method that takes in a sales amount and returns the tax, which is a double value. So if our sales amount is less than 100, we're going to return 0.01. Okay, so this is your tax amount. If our sales amount is less than 200, we're going to return 0.02. Otherwise, we're just going to return 0.03. So taking a look, what would need to be tested for the boundary cases? Okay, so we want to test our boundaries. So for our get tax, we'd want to pass it a value of 99 and ensure that 99 is less than 100, so it should get a 0.01. We want to pass it a 100. It's not less than 100, but less than 200. We would expect a value of 0.02 and maybe pass 101 as well and expect a 0.02. And then here we'd want to do 199, expecting 0.02. 200, which should give us a 0.03, and a 201, which would give us a 0.03. And then maybe we want to just go way up, do a 500, make sure we get 0.03, and maybe go with a 10 and make sure we get 0.01. You can never test something too much, right? It'll never hurt to have additional test cases, but it certainly might cause you problems if you don't have enough test cases. So better to have too many test cases to give you confidence that your method is working as intended than to not have enough test cases and find out that your program is not working correctly. All right, so here's an example. We have this scenario. We have an assignment class. This is a user-defined data type. We have the methods set name and get name. So this, your assignment might be like exam 1 or homework 1. We have the set score and get score and then get grade. So in this assignment driver class, we have a program. This prompts the user to enter their assignment name and their score and then displays the grade. So maybe we set the name as homework 1 and we set the score as a 19, and what would be their grade for that particular assignment, kind of a thing. Okay. Oh, well, let's go back. So if we were black box testing it, we would use the driver program and we would enter in the name and enter in the score and then check that the grade that's returned is correct, right? And we would do this multiple times. So this would be our black box testing, is testing it from this perspective where we're entering in a name and we then enter in the score, and it should come back and say on assignment, you know, homework 1, you got a grade of blah. And we would do this multiple times to make sure. We would make sure that we entered in a grade that would be failing, a grade that would be a D, a grade for every single thing, A, B, C, D, and E, and make sure that it always came back with the correct. And we'd want to, as a user, enter in some boundaries, something close, make sure it always returned to us the proper score. For white box testing, we would test the user-defined data type, and so we would write a method to set the name and then check to make sure that it had been correctly set. And then we would write methods to set the score and make sure that those were properly set. And then we would want to write methods to actually retrieve the grade. So again, we'd want to hit those boundaries. We'd want to hit set a score that would force us to get an E and hit the boundaries of the E, like maybe, something obvious, 25, which is obviously an E, and then maybe right at 59, which is still an E, and then we'd want to hit 60, which should give us a D, and 61, that gives us a D, and then likewise go to 69, which is still a D, a 70, which is a C, 71, and so on. We'd want to write enough test cases to ensure that the grade that is returned is correct on all of the boundary levels of our particular assignment class. All right. So black box testing is testing the driver program from the user point of view, which is what I just reviewed for you. So this is where we're just really using that program as a user would use it and ensuring that everything that's happening is as expected. Okay, so here's our driver class. So we would prompt, enter an assignment name. Does it look like it was saved? Does it look like it returned to us the name that we just entered? We'd enter an invalid score, maybe a negative number like -10. What ends up happening? Maybe 110. What ends up happening? Then we enter a valid score. What ends up happening? And then we enter a score that should have a grade. Do we get the grade that we're expecting? Do we allow for B minuses or B pluses, or what does it do? And we would test this for all possible scores, ensuring appropriate code coverage. Okay, so this is from a driver class perspective. From the white box testing, this is where we're testing the program from the programmer's point of view. So we're really testing that user-defined data type class. And so we're going to write a unit test for each method. So one for each constructor, one for each set get, one for the test grade, and we're going to, or get grade, and we're going to make sure that this get grade tests all possible branches and all possible boundaries. And if we're supposed to return plus and minus grades like B pluses, B minuses, we're going to check and make sure that it returns the appropriate value in those circumstances as well. And so this get grade would actually be quite robust, right? We're going to have a ton of tests. We're going to be setting the grade, probably 3 different times for an E, 3 different times for a D, 3 different times for a C, and so on. So you're going to have at least 15 test cases, and then you're going to want to hit some invalid grades, such as a negative score on the test, which shouldn't be possible, right? The lowest you should be able to get is a 0. So what happens if you get a -10 on an exam? What should it return? What happens if it's greater than 100? What should it return? So you're probably going to have 17 or so different test cases for that get grade just to ensure that it's working correctly. All right, so the last thing for today, so like I said, a very short session, but kind of nice, but very important to understand the difference between black box testing and white box testing is regression testing. So regression testing, if you think of regress or regression, it's kind of like going back. So think of it as going back to your childhood. It's making sure that all the previous functionality of a program continues to work as well as all new functionality. Okay, so all of the previous test cases should still pass as well as all new test cases. So kind of think of your own desktop or laptop computer or whatever it is that you have, and you have programs installed, and if you were to put on a new version of your operating system, we get those updates all the time, right? And all of a sudden everything stopped working on your computer. Everything. That would mean that the operating system developers did not conduct appropriate regression testing. They did not make sure that everything that had already worked continued to work, and that's why everything crashed. So when you have a program, you want to make sure that all previous functionality that's still valid continues to pass the test cases. So you want all previous functionality to still pass all of your test cases as well as all new functionality. So you don't really eliminate your old test cases, you continue to keep your old test cases and you add to it with new functionality. So you're making enhancements or improvements to your function. You want to make sure that everything that previously worked still works and all of your new stuff works as well. And that is what is regression testing, making sure that all previous functionality continues to work as well as all new functionality. Okay, so that is it for this really short session in week 6. Certainly, if you have any questions, please do not hesitate to send me an email or post these out on Piazza if you have any questions. And as you're taking a look at your homework or your labs this week, please, take a moment to just kind of say to yourself, okay, this is white box testing, or this is black box testing, or I can see how we're implementing regression testing here.